Hey everyone, thanks for making time to watch this. NASA is getting ready to hold pre-flight briefings to preview the Artemis II test flight and lunar flyby mission next week in Houston. At the Kennedy Space Center launch site in Florida, Exploration Ground Systems continues to make progress towards final assembly of the flight hardware. Orion is now encapsulated for launch, and the connector between the spacecraft and rocket is being prepared for stacking first. It looks like I'll be on Artemis II watch until the mission, so I'll go through that first, and then there was also news about the Artemis III Orion, a Gateway delivery milestone, and newly released SLS production pictures. We got a couple of pictorial updates on preparations to get the final two elements of the Artemis II vehicle ready for stacking this week. The Artemis II SLS is more or less stacked, and its integrated testing is complete. The two boosters, the two stages, and the connector between them have been checked out. The last two elements to head to the vehicle assembly building and be added on top of SLS in High Bay 3 are the Orion stage adapter and the Orion spacecraft itself. The OSA will carry a few CubeSats as secondary payloads. 4 of them are on the current manifest, and we got a set of pictures from the Multi-Payload processing facility where it is being prepped for transport and stacking. Pictures taken on Wednesday, September 17th and published the next day showed that 3 of the CubeSats are now installed in payload deployment dispensers in the OSA. Based on previous pictures of the South Korean and Saudi spacecraft in the MPPF, and the notes with the pictures here saying that the German CubeSat is also now installed, that leaves the status of the CubeSat from Argentina open. In the Launch Abort System facility, Exploration Ground Systems is finishing encapsulation of the Orion crew module with the Launch Abort System. Early in the week, NASA Kennedy Space Center Public Affairs published pictures taken on September 10th showing 2 of the ogive-shaped fairing panels in place, along with other fittings that are installed around the base of the fairing. At the end of the week, a new set of pictures taken a week later showed the remaining 2 panels installed, so all 4 of them are now in place. That leaves work to get all the fasteners between the panels secured, functional testing of the hatches, and thermal protection system closeouts. The latter is the room temperature vulcanizer material that looks like caulk when it's applied and serves as both a weather seal around seams, such as where the 4 ogive panels are fastened to each other, and it also serves as TPS for aerothermal heating of those areas as the vehicle ascends through the lower atmosphere. Bigger picture, those next steps are basically final pre-stacking preparations. After that, we're looking to see the OSA transported from the MPPF and the KSC industrial area to the VAB. The OSA will be lifted on top of the SLS in-space second stage, the interim cryogenic propulsion stage, or ICPS. Then we'll be looking for Orion to head to the VAB in its launch-ready configuration, with the spacecraft encapsulated by fairing panels around the service module and by the LAS on top and around the crew module. The spacecraft adapter cone is also encapsulated, and when Orion is lifted into High Bay 3 for stacking, that's what will be mated to the OSA. EGS continues to plan for that Orion move to the VAB early next month in October. Also during the week, KSC PAO posted imagery of the Artemis launch team in Firing Room 1 of the Launch Control Center there. Still images and video were taken on September 11th during the first Joint Integrated Launch simulation. That involves launch control across multiple firing rooms and support rooms in the Launch Control Center, flight control and support rooms in Mission Control at the Johnson Space Center, and engineering support at Marshall Space Flight Center. On launch day, that would include multiple shifts at those locations to support the hours-long timeline from propellant loading through crew ingress, terminal countdown, liftoff, and orbit insertion. Launch continues for hours more before Orion separates from SLS. There's a perigee raise maneuver and apogee raise burn by the SLS second stage before Orion is released. The crew will then perform a proximity operations demo using the ICPS as a practice target, manually flying Orion and getting data on handling qualities while making close approaches to the stage. After the demo, Orion will separate from the ICPS, OSA, and spacecraft adapter cone, which will end the launch phase of Artemis II. Maybe not the official launch phase, and the Joint Integrated Sim may not have completely covered that several-hour sequence, but these multi-center practice exercises will cover large portions of those critical phases of Flight Day 1. On Wednesday, September 17th, NASA Marshall Space Flight Center published a feature on the Artemis II SLS, running through some of the smaller scale changes to this flight article when compared with the Artemis I vehicle. That first launch for the program and of the Block 1 crew configuration was successful. The article notes a few changes that are intended to address in-flight anomalies and improve payload performance. Two of those changes revolve around separation of the solid rocket boosters. The boosters will be jettisoned 4 seconds earlier on this launch, about 2 minutes into flight. By releasing the empty cases sooner after they aren't providing any thrust, they are hoping to get an additional performance benefit of approximately 1,600 pounds or 725 kilograms. The separation motors were also angled an additional 15 degrees to provide more clearance from the rest of the vehicle when they fire. There are SEP motors in the top and bottom of the boosters, but the feature doesn't specify whether the forward motors were adjusted, the aft motors were adjusted, or both. The feature does note the strakes that I've reported previously, but it also talks about improvements to the navigation system, repositioned antennas, and updates to the Power Data and Control Unit, or PDCU. There are 2 PDCUs mounted in the inner tank. Pre-flight briefings for Artemis II are coming up next week in Houston, and ahead of that, NASA published more features like this during the week. Another one was published about the strakes and analysis and testing of that as a solution to the vortex issue seen during the Artemis I launch. Data from development flight instrumentation installed in hundreds of locations on the exterior of the vehicle showed higher vibrations than modeled/predicted during the transonic region of the launch around a minute after liftoff. After trading a few options, the SLS program decided to add strakes to reduce the buffeting during that period of ascent. The feature provides some visualizations of the airflow around a booster to core stage forward attach point, with and without the strakes. It also talks about wind tunnel testing and analysis performed on different options at NASA's Ames Research Center in the San Francisco Bay Area. The strakes will be attached to rails already added to the core stage intertank structure. The feature says those will be installed in October, and then hopefully we'll get to see what the final configuration looks like on the vehicle in the VAB before it rolls out. Those pre-flight briefings are scheduled for Tuesday and Wednesday, September 23rd and 24th at the Johnson Space Center. This first crewed test flight of SLS and Orion, being launched by Exploration Ground Systems, will be previewed on Tuesday morning beginning at 9 a.m. Central, 1400 UTC. That starts with a mission overview briefing, followed by a mission science and technology briefing at 11 a.m. Central, 1600 UTC. On Wednesday, September 24th, the Artemis II flight crew will hold a news conference at 9 a.m. Central, 1400 UTC. NASA will live stream those briefings, and I have put links to the scheduled YouTube live streams in the description. On Tuesday, September 16th, the European Space Agency announced that they had formally turned over the European Service Module for the Artemis III Orion to NASA. ESM Flight Model 3 was delivered to the Kennedy Space Center a year ago in September 2024 and was mated to the crew module adapter shortly thereafter to form the full Orion Service Module. After the elements were bolted together, fluid line welding and electrical mates were completed to fully integrate them. A picture was taken of the ESM group in Lockheed Martin's Orion production area at Kennedy Space Center and published with the announcement. The picture shows where the Artemis III service module is currently stationed, sort of in an aisleway in the Industrial Operations Zone in the Neil Armstrong Operations and Checkout Building in the KSC Industrial Area, basically where the Artemis II service module was for a time in 2023. The IOZ is refilling with Orion hardware again after Lockheed Martin handed over the fully assembled Artemis II spacecraft to NASA Exploration Ground Systems at the end of April. As I reported last week, the pressure vessel for the Artemis V Orion, the core of the crew module, was trucked to KSC at the end of August. That delivery unofficially started Artemis V Orion assembly and test there, which will run in parallel with the Artemis III and IV builds. Also noted in last week's video, those builds are the first trio under the Orion production and operations contract that started in 2019, and would be the first 3 to be reused. The Artemis III crew module would be refurbished after return to fly Artemis VI, Artemis IV would be turned around for Artemis VII, and the Artemis V crew module build that is just starting would eventually be reused on Artemis VIII. ESA also notes that Airbus is finishing standalone integration of ESM Flight Model 4 before that is delivered to KSC later this year for the Artemis IV spacecraft. The priority for Lockheed Martin now is finishing assembly and test of the Artemis III spacecraft. With the formal handover of the ESM to NASA, I asked PAO about the status of the initial power-on milestone for the service module. Earlier in the year, the crew module IPO was completed, and at the time, the service module IPO was forecast for the fall. However, PAO now says that milestone was already completed last month in August. Lockheed's goal is to deliver the Artemis III spacecraft to EGS in the fall of next year. That's basically the end of 2026. If they are able to do that, it would at least keep that part of the Artemis III puzzle on the mid-2027 schedule for launch. On Monday, September 15th, Busek announced that they had delivered all 4 of their 6-kilowatt Hall thrusters to Power and Propulsion Element prime contractor Maxar for eventual installation on the Gateway element. The PPE and the Habitation and Logistics Outpost modules will be launched together no earlier than 2027. Busek's 4 thrusters will work with the 3 12-kilowatt Advanced Electric Propulsion System thrusters that L3Harris developed for the PPE. L3Harris has already shipped those 3 thrusters to NASA Glenn Research Center for acceptance testing. NASA Glenn Public Affairs says that the first 2 have completed that testing, one of the thrusters has already been delivered to Maxar, and delivery of the second is expected this month. The third AEPS thruster is currently going through acceptance testing. PPE also has a more conventional bipropellant system, but it will use its solar electric propulsion for the large translational maneuver from the Earth to the Moon after launch. The 2 sets of thrusters, the 3 AEPS thrusters and 4 Busek Hall thrusters, will be fired continuously for days and weeks during the spiral out from a geostationary transfer Earth orbit to the Gateway orbit, also known as a near rectilinear halo orbit, or NRHO. Or more specifically, a southern L2 NRHO with a 9:2 resonance with the lunar synodic period. In other news and notes for the week, NASA Michoud Assembly Facility posted imagery of Core Stage-3 liquid oxygen tank milestones from a month ago in late August. We'd last seen the tank in early July after the main thermal protection system applications were complete, and it was moved into Cell A in Building 110 for installation of the sump in the aft manhole of the tank. Still and edited video were posted on September 17th and 18th, showing the tank being removed from Cell A following that installation. We can see the newly installed sump, or, well, the exterior of it. Those 2 holes are where the 2 LOX feed lines will run, starting there, running out of the inner tank, down opposite sides of the LH2 tank, and then into the engine section. Or if you think of propellant loading, the LOX will flow into the engine section first, through the main propulsion system lines in there, up those 2 downcomers, and into the LOX tank. Those 2 LOX feed lines, which branch further in the engine section, are assembled in segments. The S ducts that run from the sump out to the exterior of the inner tank will be installed as a part of the forward join work. The breakover operation performed the Cell A installation steps in reverse. One of the overhead cranes in Building 110 was attached and lifted the tank out of the cell and out into the transfer aisle. The second crane was attached, the tank was rotated to horizontal and connected to a Rotation, Assembly, and Transportation Tool, or RAT. The tank rat is one of a few types of ground handling carriers used at MAF. The second set of imagery posted this past week showed the tank being moved on that pair of rats from the Building 110 transfer aisle to the final assembly area in Building 103. I'd asked if the tank was in Area 6, but these images show that it was moved to the Area 47 footprint of the overall 47-48 final assembly area. That was not quite a month ago, and Boeing would be working on outfitting the tank prior to the forward join. Based on previous builds, the remaining tasks would include installation of the internal sensor mast, which holds the liquid level sensors that provide launch control and flight control systems and teams with situational awareness about how much propellant is in the tank. That's used to pace propellant loading before launch and as a part of the engine cutoff logic in flight. The LOX tank was parked alongside the Core Stage-3 LH2 tank, which is being prepped for the upcoming joins of the upper 4/5 of the stage. The engine section for the stage is at Kennedy Space Center in Florida, but the rest of the main elements are at MAF in New Orleans. The forward skirt, LOX tank, and inner tank will be joined to make the forward join subassembly, and then eventually the LH2 tank will be attached to that. Before that major join, the LH2 tank will be mated to an engine section simulator that will stand in for that element during ground and sea transportation to KSC. That LH2 tank to simulator mate is called the aft join, and we're waiting to see when that might happen. In the pictures from late August, taken inside the final assembly area, we can see enclosures around both ends of the LH2 tank. In this one, we can see the aft manifold has been installed, but the LH2 pre-valves are still not in place yet. One of the operations in the background of this late August imagery at MAF is a Core Stage 4 propellant tank in the Vertical Assembly Center friction stir welding tool. According to Boeing, that's the LH2 tank, and that could play a role in the upcoming traffic patterns in Building 110. Once VAC welding of the tank is complete, it will need to move to Cell A for some post-weld work. The Core Stage 3 LH2 tank, though, also needs that cell for the aft join with the engine section simulator. And the LH2 tank for the Exploration Upper Stage Structural Test article needs the VAC to complete its major welds. What traffic pattern is planned by Boeing and the priorities for the different processing cells are questions I used to ask them about. Going back to the LOX tank move last month, we can see that Area 47 was also empty, so the Core Stage 3 inner tank had vacated that location. We had previously seen it there since as early as January and as late as April. Boeing has not said where it is now, but it would be moved into Cell D in Building 110 as a part of the upcoming forward join work, whenever that is planned. Late Friday afternoon, September 19th, NASA announced they were awarding Blue Origin with a task order to fly the Volatiles Investigating Polar Exploration Rover, or VIPER, in late 2027 on the second Blue Moon Mark 1 flight. The news release says that the first Mark 1 lunar lander flight is targeted for launch later this year, but the uncrewed lunar lander is not on the manifest for the second New Glenn launch, which doesn't have a firm launch date. Subsequent launches are expected next year. A second Mark 1 lunar landing in late 2027 would be significantly later than Blue Origin's plans in 2023, which was to launch those two uncrewed lunar landers in 2024 and 2025. However, it's not clear how those delays affect development of the Mark II crewed lander and system, which also includes a separate cislunar transporter spacecraft that will be refueled in Earth orbit. Earlier in the year, a Blue Origin official had said that the hardware for the second lander was expected to trail the first by about 6 to 8 months, but now they will be integrating a specific payload with it. Designing a surface deployment system for the rover post-landing is a part of the task order award base. NASA has an option to buy implementation of that design and actual deployment of the rover, which will be evaluated after the first Mark 1 mission is complete. In political news and notes, Congress is now focused on passing stopgap funding to begin fiscal year 2026. This is the continuing resolution that starts every fiscal year nowadays. Since the deadline is still a week and a half away, the other tradition that is building for CRs is to play games with it. So the expectation is that that game of chicken will run right up to the deadline or maybe beyond it. Like most things in Washington now, the FY 2026 budget for NASA is controversial, with two different plans for funding. At a high level, the White House cut the science budget in half and canceled most of Artemis. Congress is controlled by the same political party, but they are the ones that endorsed and funded previous plans, and they quietly still support most of them. The House and the Senate drafted budgets that largely maintained the previous plans. Rather than the 25% cut in the White House plan, both bills keep NASA's top line flat, nearly the same as fiscal year 2024, which is the last budget approved in Washington. The House bill vibes, so to speak, a little more with the White House on science, cutting that significantly, but still significantly less. None of those plans are enacted law yet. However, NASA is a part of the executive branch, controlled by the White House, and they had signaled they were going to follow their plans beginning on October 1st when the fiscal year begins. On Friday, September 19th, Ars Technica published Eric Berger's story reporting that in the likely event that there's no NASA budget enacted by October 1st, the White House may allow NASA to use the funding numbers from the House bill. I put a link to Eric's story in the description. The future of Artemis for the rest of the decade is built on its budget, and there's no longer any certainty about it, so I'll be continuing to monitor news and developments here. What happens to plans and schedules for Artemis III, Artemis IV, and beyond will be directly impacted by what happens with the budget, and if there's a government shutdown, that could also affect Artemis II. Thanks for watching. Like and subscribe if you find these videos informative and want to find out what's going on with Artemis every week. Big thanks, as always, to the members of this YouTube channel who are helping make it possible to keep doing this. I am posting additional content and updates if you're interested in joining. If you're willing to make a one-time donation to help support what I do, I would really appreciate it. I put a link to my Buy Me a Coffee page in the description. Thanks again, and I'll see you next time.